We start with some discussion of population and sample. These are some very important words that we're going to be using throughout the course. A population is the entire group of individuals about which we want information. So for example, maybe we would be interested in all college students in the US. It's not feasible to try to talk to all college students in the US. So we would try to come up with a sample of all college students in the US that we believe to be representative of this population. Supposing that we have the budget to contact 100 students, our goal would be to put together a sample of 100 students that we believe to be representative of the population. What that means is that they would share the key characteristics that we think are important for the purposes of whatever it is we're trying to measure. Now, that's very easy to say, but much harder to do. So we can take a look at some examples of where this was attempted, some fairly famous examples of botched presidential election predictions where this was attempted but not done successfully. First, we have 1936. In the 30s, the first thing we often think of is depression, and that would be an accurate way to start thinking about this first one in Landon versus Roosevelt. How many of us have heard of Alf Landon, if not in the context of this botched presidential election prediction? I would say probably not many, but of course we've all heard of FDR, Franklin Delano Roosevelt. Well, the Literary Digest survey predicted that Alf Landon would be the winner with 57% of the vote, which is a pretty strong majority. And as we know, FDR won that. This is Depression era, and the people polled were magazine readers, car owners, or telephone customers, because this is how people were reached. Car registration, through ads in magazines, and through telephone calls. So in the Depression era especially, this was contacting primarily wealthy people. A lot of people couldn't afford these things in 1936. So the candidate who represented the more wealthy people was predicted to be the winner. Going on to 1948, we might think we've learned a few things now. There was another famous incorrect prediction. Dewey defeats Truman was a headline on the Chicago Daily Tribune. You'll have no problem pulling up images of that on any Google search of Dewey versus Truman. The papers, of course, have to print these headlines before they know the results because it takes time to get their papers printed. So they printed up both possible results, but the wrong ones hit the newsstands in some areas. So in this case, quota sampling was used. So learning from 1936, we're trying to make sure that we capture people in key demographics of the population. If you can decide in advance what those important characteristics are and know in what proportions they're present in the whole population, you can try to match that. Well, the problem with this is that you have to have a list of those key characteristics, and you have to make sure that those are the only things that matter. When human beings are in charge of trying to gather this data, there are all sorts of subconscious biases that come into the process. If it's a person on the streets soliciting interviews, for example, that person will always tend to gravitate towards people who are more similar to them and maybe be more likely to get responses from people who are more similar to themselves also. So there's lots and lots of subtle biases that can come in that are impossible to put in this list of key characteristics. So quota sampling is not generally believed to work either. Now, if we fast forward to 2016, here's one that is much closer to us, one that we all just went through ourselves. Of course, there was a strong level of confidence that Hillary Rodham Clinton would win the 2016 election, and as we all know, that's not how it turned out. In this case, there have been many analyses, but the part that relates to sample bias has to do with education level. People with higher education levels generally preferred Hillary Rodham Clinton. And this is something that tends to be true across party lines, across other demographic characteristics, across income levels, etc. That even if you control for all of those things, the people with higher education levels tend to prefer Hillary Clinton. Without getting into the details of why that's true, that's something that has been established with some of these polls. Well, the reason that that caused a problem in this polling is that people with higher education levels are also more likely to participate in a survey. So when you put these two facts together, what you find is that the Hillary Clinton supporters are just easier for the pollsters to reach than the Donald Trump supporters. And so naturally, they're going to come out overrepresented in the polls. Now, there are all sorts of other things that make prediction of presidential elections difficult. For one thing, the best any poll can possibly do is estimate the current state of something that is always changing. So, as we know in the 2016 election, there was also a lot of new information coming out as the election got closer. These factors may have played into the 1936 and 1948 elections as well. These ones aren't nearly as close to us, so it's a little bit harder to know. But since right now we're really focusing on sampling bias, these are the details in particular that relate to sampling bias that stand out in these three elections. There are a few classifications of sampling bias. Undercoverage is when the sample isn't chosen to be representative of the population. So this is the problem we had in 1936 and possibly 1948 also. In 1936, the issue was it's the Depression, and we're forming our sample on the basis of vehicle registration and telephone listings, for example, right? So the forming of our actual sample is already flawed. Non-response is what occurs after the sample has been created when we're trying to contact the sample. This is really our 2016 problem, right? So non-response was responsible for the Clinton election, the Clinton-Trump election, because as pollsters were attempting to contact people and get them to participate in a survey, they found more participation among the Clinton supporters than among the Trump supporters. A voluntary response, and a subset of this would be a convenience sample, is a little bit different situation because there's no formal sample ever created. This is like your Yelp, right? Everybody's gone to Yelp, and it's helpful to go there and read reviews about places. But of course, as you're reading these, you probably get the sense that you're not looking at a perfectly representative sample of everybody who has eaten at this bistro, right? What it generates is strong opinions. I mean, it doesn't generate the strong opinions, but that's what ends up getting reported. So we see only strong opinions in these situations. And it may be helpful to know about a few people's situation somewhere and a few people's experience, but it's definitely not something that we would use to infer about the whole population. Another example of this might be like an internet survey, right? Where the survey form is given on the internet and anybody can show up and fill it out. If we're not tracking who we attempted to contact and how many of those actually participated in the survey, then it would be considered a voluntary response kind of situation. This is the worst. I mean, all of these can be very bad depending on the severity of the problem, but in all of these situations, we would consider this sample to be not useful for inference about the population. So let's take a look at one more example here. Donated brains from deceased former NFL football players. Of course, if their brains are being donated, we would hope that they are not still living. In 111 donated brains, we see evidence of this neurodegenerative malady known as CTE in 110 of them. So we can tell without doing any mathematics at all that that's very high and very close to 99%. In fact, a little bit higher than 99%. And so the question here is, can we conclude that somewhere around 99% of all NFL football players suffer from CTE? So it is the job of statistics to take a sample and see what we can infer about the population. So the fact that we don't have all of them is not really the issue here. The real issue is the fact that these are donated brains. And you have to wonder, what sorts of people, I don't mean this in a judgmental way like it's sounding when I first start to say it, but is there any characteristic that we think might be true of people who donate the brains of their beloved family members who played football for the NFL, right? And it does seem reasonable that a person would be really motivated to do that if, knowing this person throughout their life, they saw evidence of brain trauma, right, in the person's behavior and in the person's interactions. So part of the potential for bias here comes from the fact that these brains were donated by the family members of the player. Another part of the bias is we're only looking at deceased players, right? So it's certainly possible that players with healthy brains live longer, right? It's possible that there is an overabundance of available deceased NFL players who had neurodegenerative maladies. So one could imagine that it's possible that maybe players who died prematurely are more likely to end up in this pool and having their brains donated to this study. So the only way we could really know anything about the prevalence of this is if we could define a sample of players and then wait and then hope that all of their family members, or that a large number of the family members, agree to donating their brains to science. It's an incredibly hard thing to measure, and these challenges are present in just about everything that we try to gather data on. We don't really learn in this course how to do everything perfectly, but we do learn a few things to look out for and a few things to notice before we fully trust the results of a study.